Okay, as I just shared in that yesterday material, so not the design of CS, sorry, that CMOS amplifier, the other one, the Nyquist plot. So let us try to understand, okay, how to plot the Nyquist plot and all those stuff. So for that, let us try to understand some basics of control system which we already know. Suppose if this is the open loop transfer function of a unity feedback system which has got something like 2 by s plus 2. So what does this actually mean? Okay, suppose if you are asked to write the pole 0 plot, where is the pole of this transfer function? Can somebody just unmute? Okay, pole is there located at -2. Suppose if I do 1 plus GFS into HFS, just 1 plus GFS into HFS, not equal to 0. So what I'll write it as? So I can write it as 1 plus 2 by s plus 2, so that I can write this as equal to, so what will be this? It is s plus 2 by s plus 2. So then this becomes s plus 4 by s plus 2. Correct? Can somebody unmute? Nauda or whoever? Hello.
Yes, sir.
Yeah. So now we can see for this transfer function GFS into HFS, there is a pole at -2. Correct?
Yes, sir.
Now we have slightly modified the transfer function and wrote it as 1 plus GFS into HFS. Now upon this, can you see now? So there is a pole at -2, there is a 0 at -4. Because whatever that
-4.
is there in the numerator is 0, what is there in the denominator is a pole. Correct? Yeah.
Yes, sir.
So let us also write CFS by RFS for the same thing. CFS by RFS for the same thing. So will it be equal to, because HFS is equal to 1, can I write it as GFS by 1 plus GFS into HFS as my closed loop transfer function? Is it not 2 by s plus 2 by 1 plus 2 by s plus 2?
Yes, sir.
Okay, will it not reduce to s by s plus 4?
2 by s plus 4. Yes, sir.
Correct? So
Yes,
now
sir.
suppose if I write the pole 0 representation of this CFS by RFS, so will it be something like this?
Pole at -1.
So now all these are S-plane representation. S-plane representation. So this is in S-plane. So all of them are in S-plane. Correct? So let us try to understand a few points here. You can see what is this? This is a pole of open loop transfer function. Am I correct?
Yes, sir.
Poles of open loop transfer function, is it not equal to poles of 1 plus GFS into HFS? If you can see this and this,
Yes, sir.
if you can see these two, are
Yes,
these two
sir.
not same?
Yes, sir.
Correct? Now I will write zeros of 1 plus GFS into HFS. Is it not equal to poles of
Pole.
CFS by RFS?
Yes, sir.
Correct? Meaning this and this are same. It will be always. It will be always. What I mean to say is zeros of 1 plus GFS into HFS are nothing but poles of CFS by RFS, or nothing but closed loop poles. Shall I write?
Yes, sir.
Closed loop poles. Shall I also write zeros of 1 plus GFS into HFS? Is it not equal to roots of characteristic equation? Zeros of 1 plus GFS into HFS, is it not the roots of characteristic equation? Okay, what is characteristic equation here? Here in this case, is it not s plus 4 is equal to 0? Is it not the characteristic equation in this example?
Yes, sir.
What are the zeros of 1 plus GFS into HFS? Is it not at -4?
Yes, sir.
What is the root of this characteristic equation? Is it not -4?
Yes, sir.
So Let us try to again recap. Poles of open loop transfer function, that is denominator of GFS and HFS, is nothing but denominator of 1 plus GFS and HFS. Is that fine?
Yes, sir.
Then zeros of 1 plus GFS and HFS is nothing but poles of closed loop transfer function. Done?
Yes, sir.
Okay. With this idea, we'll go to, okay, all of you can just open the presentation or the slides or the material that I given for Nyquist. That is, what is that? PDF. On 6 pages PDF. Let me just open that. Where is that? Okay, it's here. If you can see here, is it visible now? Hello? Hello?
It's visible, sir.
Fine. Okay, can you see? Okay, this f of s is nothing but 1 plus GFS into HFS. F of
Yes,
s
sir.
is nothing but, of course, 1 plus GFS into HFS. It is having only the numerator, there is no denominator. Correct? Can you see the numerator is s into, sorry, 2 into s plus half. In the denominator, there is nothing.
Yes, sir.
So, does it mean that it has got a 0 at minus half?
Yes, sir.
Can you see here? There is a 0 represented here.
Yes, sir.
So, this is in S plane. I have represented the 0 of f of s, which is nothing but GFS into HFS. So, I will just rewrite this as f of s. See here? Shall I write it as f of s?
Yes, sir.
So, what I have now is, let me rewrite. F of s is equal to 2 into s
1.
plus half. Correct?
Yes,
So,
sir.
the 0 is located at minus half. Done?
Minus 1 by.
Now, we have a contour. Can you see there is a closed loop contour
Yes,
at
sir.
A, B, C, D?
Yes, sir.
Okay, now let us consider A, B, C, D. What may be this A? Is it not 1 plus J1? See here,
Yes, sir.
real part is 1, imaginary part plus J1.
J1. Yes, sir.
Is B is equal to 1 minus J1?
1 minus J1.
Is this is minus 1 minus J1?
Yes, sir.
Is this minus 1 plus J1?
Yes, sir.
Exactly that over here. Can you see here? Point A is this. This is intermediate point. So this is 1. This is okay, 1 minus J1. This is minus J1. This is what? Minus 1 minus J1. This is minus 1. Okay, they have taken contours here. Can you see here? Is it not
Yes,
the
sir.
points corresponding to this contour? Contour is nothing but a closed path. Is that fine?
Yes, sir.
Okay.
Yes, sir.
Now, what we'll do is, you have this expression on s here. So, 2 into s plus half. Hello?
Yes, sir.
Okay, in this value of s, you substitute these values. So, this is now the s value. It is 1 plus j1, 1 minus j1. So, these are all the s values. You substitute the value of s, that is, what is that? 1 plus j1, 1 minus j1, minus j, and then minus 1 minus j1, minus 1, minus 1 plus j1. If you substitute all those values of this contour onto this f of s value, can you see you will end up with these points? Correct?
Yes, sir.
How we are getting these points is just substituting the value of s as this. Correct? Okay, let me just do for only one value. So let me take s is equal to, let me just do it here.
1 plus.
Let me just take a simple one. So s is equal to 1, I'll take. If I take s is equal to 1, is it not 2 into 1.5? Is it not 3?
Yes, sir.
Meaning, what I mean is, this point, what? This point in S plane is nothing but this point. Am I correct? 1 what we are having. Can you say this is 1?
Yes.
Is 1 is now replaced by 3 in this f of s plane.
Yes, sir.
Likewise, if you substitute for each and every values of this a, b, c, d and the intermediate values, I'll get these as the contour values. Correct?
Yes, sir.
If you take these contour values and join them, you will get this closed path. Correct?
Yes, sir.
What we are trying to do is, let me just show you. What we are doing is, we have a 0 of f of s. I wrote a contour here. Correct? I write
Yes,
a
sir.
contour in this direction. You can see the direction of the contour is something like this. Correct?
Yes,
This
sir.
is in S plane. This is in S plane. Then we have it as, okay, we just suppose, I think it went like this. Correct? So this is your contour. It is, okay, J1, this is 1, this is minus J, this is minus 1, something like that. Correct? So for each and
Yes.
every point, do you have a corresponding, okay, this 1, is it not 3 now in f of s plane? What is this f of s
Yes, sir.
plane? When you substitute the value of s as 1, value of s as plus 1 minus j1, and this is minus j, this is minus 1 minus j1, will you get different set of values? So using
sir.
that, I will going to write a contour. I'll write a contour. So upon writing the contour, you can see I got this. Can you see here? I got this one.
Yes, sir.
If you see this contour, so now we will define two things. So one is called as enclosure. You have a contour, assume that you have a 0 here, you have a 0 here. I'll write a random contour. I'll write a random contour. When I write a random contour, can you see, is this 0 coming to the right of this direction? I'm just traveling here. Assume that you're traveling here. So where is this 0 seen? Is it towards right or is it towards left? Is it not towards right?
Right.
So
Yes, sir.
is this, suppose if there is a 0 towards the right of it, right of this contour, I'll call it as enclosed. What is enclosed? A 0 is enclosed by the contour. Correct? Suppose if I have an
Yes.
example, I'll have a 0 here. Suppose if I have a contour like this,
It's to the left.
it is to the left, I'll say it is not enclosed. So if you have any polar 0 towards the right of that contour, I will say it as enclosed. If it is
Yes,
to the
sir.
left, I will say it as not enclosed. Done? Assume that
Yes, sir.
I have something like this now. So to this
Poles.
contour, 1 0 is enclosed, 2 poles are also enclosed.
Yes, sir.
If I write like this now, I'm just simply taking some random poles and zeros. Can you see now? Even though I have these many poles and zeros, only 2 poles and a 0 is enclosed, whereas these 2 are not enclosed. Correct?
Yes, sir.
Meaning to say, suppose if I have something like this. If you have something like this, if I write a contour which is having this direction, how many are enclosed? Can you see now?
All are enclosed.
3 zeros and 3 poles are enclosed.
Yes, sir.
Suppose if I write it like this. Now,
Only 1 0 is enclosed.
this is coming to the left of it. This is my contour direction. Now nothing is enclosed. Even though it is inside, since it is, you can see the direction. Direction is this way. Is it to the left of it?
Yes, sir.
This 0 is maybe inside. You can see the direction. Direction is going in anti-clockwise direction. This comes to the left of that contour direction. So I will say nothing is enclosed, not enclosed. Suppose if you have 0 here, now you can say two zeros are enclosed,
Yes, sir.
because these two zeros are coming to the right of that contour direction. Correct?
Yes, sir.
See here, these two zeros are coming to the right. That's why I'm saying it as this is enclosed, whereas even though it is inside that circle, I'll say it is not enclosed because it is coming to the left of it. Correct? So this
Yes,
is
sir.
about enclosure and not enclosure. How do we define enclosure now?
If a 0 is coming to the right of the contour, then it's enclosed.
Either zero or pole.
If it
It can be
is
either a
0
zero
or
or pole. Fine. Done.
yes, sir.
Now the important thing here is, if there is a zero of f of s, keep in mind, if there is a zero of f of s is enclosed by a contour in s plane, then the origin, is this not the origin?
Yes, sir.
The contour, is this not the equivalent contour of this in s plane into f of s plane?
Yes, sir.
I have, because when we actually mapped it, is it one-to-one mapping here? Can you see this is this, this is this, this is this, this is this, this is this? Correct?
Yes, sir.
So these are, of course, it is not actually 3. So what I wrote was this is 3 because this is what we have it as. Okay. So each and every point, if you see it over here, can you see all these points? They have each and every point are mapped here. When you actually see this,
Yes.
is this point, is this A is equal to this? Is this 1 is equal to this? Is this minus 1 is equal to this? So they are all one to one. They are all one to one. So what I'll say is, this contour is mapped down to f of s plane. Just a minute. Show this. Okay. 1 second. Okay. Each and every point of contour in s plane is mapped down to f of s plane. Correct? So
Yes, sir.
in this s plane, there is a zero of f of s enclosed.
Yes, sir. It's enclosed.
The argument here is, or the takeaway point here is, how many number of zeros are enclosed by a contour in S plane, those many number of times this origin will be encircled by the contour in f of S plane. Let me repeat. Can you see, is there 1 0 of f of s enclosed here?
Yes, sir.
Is this origin encircled once by the contour? What do you mean by encircle is, suppose if you have something, if this is the origin, if you just take one circle, is it there in the clockwise direction, you are there inside it?
Yes, sir.
So then I'll call it as the origin is encircled. Origin is encircled. So how many times it will encircle? It will encircle as many times the zeros are enclosed.
Yes, sir.
I'll just go to this example now. See now? Can you see, is a 0 is enclosed? Of
Yes,
course,
sir.
we have a different transfer function. Can you see there is a 0? Can you see there is a contour ABCD? There is an
Yes, sir.
equivalent contour in f of s plane. Can you see this origin is enclosed once in the clockwise direction because there is a 0 enclosed by this contour? I'll say this origin
Yes.
is encircled once in clockwise direction. Correct?
Yes.
You take this
Yes, sir.
example. See the example now. Can you see, there is a 0, there is a pole of f of s is enclosed.
Yes, sir.
Both are enclosed. Now, how many number of times this is encircled?
No, sir. It's not.
Not at all encirclement. Meaning, since there is a pole as well as 0, both are enclosed by the contour, the number of encirclement is always z minus p. I'll say what is this z and p. I will just say definition of encirclement. I will say n as the number of encirclement is equal to z minus p. What is this n now? Number of encirclement of the origin in f of s plane by the contour
Yes.
is equal to number of zeros enclosed minus number of poles enclosed by the contour in S plane.
Yes, sir.
I'll just take this example. Assume that I have something like this. What is the value of Z now? How do you define Z
2.
now? Z is number of zeros of f of s enclosed by the contour in S plane. All the wordings are very important. Number of zeros of f of s enclosed by the contour in S plane is nothing but Z. Is it not 2 here?
Yes, sir.
What is P on the same lines? Can you say?
It's number
Number of?
poles of f of enclosed by contour in S plane.
Perfect. It is 1. Correct? Then the equivalent contour in f of s plane will encircle the origin once in clockwise direction. Correct?
Yes, sir.
It will happen so. Because it is encircling once.
Yes, sir.
Assume that I have one more. I just added one more 0. What will be the resultant of this? So is the value of z is equal to 3?
0.
Is the value of p is equal
Yes,
to
sir.
1? As per
Yes, sir.
this, as per this, okay, how do we define n now? What is n?
2.
What
It's
is
the
n now?
number of encirclement of origin in f of s plane.
By the contour. Is it not 2 now? For this example,
Yes, sir.
so it will happen this way. We're not worried about the shape of the contour, but you see how many number of times it is encircled. You can see it's going like this, it's going like this. So how to identify the number of encirclement is draw a line here. Can you see this line is cut in clockwise once, clockwise second time?
Yes,
Can you
sir.
see is the value of n is equal to 2 now?
Yes, sir.
Is the origin encircled twice by the contour?
Yes, sir.
That's what is seen here. Can you see here? Because it is 1 and 1, it is 0, it's not encircling. It's not encircling the origin. Can you see now? We have so many poles and zeros, but how many are enclosed? What is Z? What is P?
Z is 3 and P is 1.
P is 1. Even though you have these two P's, these two are not enclosed. Correct? What should be N?
Yes, sir. It should be 2.
Can you see, is it not encircled by this contour twice in clockwise direction?
Yes, sir.
That's what is N is equal to 2. Now,
Only one pole is enclosed.
what is Z? What is P?
Z is 0, P is 1.
What is N as per the equation?
It will be minus 1, so it will be an anti-clockwise direction.
Perfect. So you can see it will certainly encircle the origin once in anti-clockwise direction because N is negative. Correct?
Yes, sir.
The whole idea is we are trying to see, depending on the number of poles and zeros of f of s enclosed by a contour in S plane, those many times, of course, z minus p will be the number of encirclement of the origin of f of s plane by the equivalent contour. Correct?
Yes, sir.
So can you people write what is ZNP? What is this here now? Number of encirclement of origin of f of s plane by the contour. What is that? Of course, n is positive if it is in clockwise direction. N is negative if it is anti-clockwise. Correct?
Yes, sir.
Then what is that?
It's number of zeros of f of s enclosed by the contour in S plane.
In S plane, correct. P is number of zeros, number of poles of f of s enclosed by the contour in S plane.
Contour in.
Perfect. Okay. With this idea, will just move. Okay, now how do we define stability of a system? Okay, don't forget we are in control system. So how do you define stability of a control system in terms of location of poles and zeros?
If it's all the poles and zeros to the left side of the plane, then it's stable.
It's stable. Perfect. Assume that this is your S plane. This is in S plane, no? This is S plane. In S plane, I don't want to see any poles here. Correct? Any poles
Yes, sir.
means it is closed loop poles. So that is more important.
Yes, sir.
So there should not be any closed loop poles on this side. So I don't want to have anything to the right hand side. Closed loop poles. You can have open loop poles, but you are not supposed to have closed loop poles. Correct? Is
Yes, sir.
okay, fine. How to ensure that we took some random contours here. We took some random contours. So we
Yes.
define a contour which is called as Nyquist contour. Nyquist contour. Nyquist contour is one which covers the entire right hand side of the S-plane. This is your S-plane. How do you cover the entire right hand side of the S-plane? What is this distance from here to here? Here to the entire end of your infinity. So I will write a contour. I will write a contour which is a semicircle, something like this, with its radius and angle e power j theta, where r is tending to infinity. Correct?
Yes, sir.
And theta, you can see theta ranges from 90 degree, 0 degree, and minus 90 degree.
Minus.
Correct? So is theta
Yes.
ranging from plus 90 to 0 and minus 90 degree?
Okay.
I want to write the
Yes,
direction
sir.
also. I want to write the direction because unless I know what is the contour direction, I cannot say whether it is closed or enclosed. Shall I say now like this? This is my contour. Is it a contour now?
Yes, sir.
So this contour, of course, here it was a very random contour. We wrote a very random contour. Now it's a bit structured contour. So shall I divide this entire contour into three segments? This is first segment, second segment, and third segment. In the first segment, is the value always j omega? Is it always imaginary?
Yes, sir.
So I will write first segment s value is equal to j omega. This is the value of different values of s it can take, no? Is the value of omega ranges
Yes, sir.
from 0 to infinity? Is it between 0 to infinity?
Yes, sir.
Correct? How about s value
Yes.
in second segment? Is s is equal to r e power j theta, shall I write?
Yes, sir.
Where r is going to infinity and it is starting from here. Correct?
Yes, sir.
And what is in third segment? Is it not s is equal to minus j omega? So it's like a relay. In this relay, there are only three runners. Only three runners. First runner will start from 0, that is j0. He'll go up to j infinity. Correct?
Yes, sir.
He hands over the baton to second person who runs from infinity at an angle 90 degree all the way down to this. He has completed his running. And the third, he'll going to hand over the baton to third runner. He runs from minus infinity to 0. Of course, minus j infinity to 0. Is the relay over? Is the relay completed?
Yes, sir.
Meaning that we have a closed contour. Correct?
Yes, sir.
Okay, now for this contour, which is something like this, let us take GFS into HFS is equal to K by S plus 4. This is GFS into HFS. This is GFS into HFS. So where do I, okay, let me just take it as some phi. Where is the pole position?
-4.
Is it not at -4? So what is this now? Is it actually j infinity minus j infinity? Is it not at infinity? Correct?
Yes, sir.
Now, what is this actually? Is this not the open loop pole of open loop pole? Is it not
Yes, sir.
also the open loop pole of f of s?
Pole of 1 plus s f of s.
Correct? See,
Yes,
is
sir.
is this, we know that open loop pole is nothing but
Pole of
poles
f.
of 1 plus gfs into hfs, which we name it as f of s. Correct?
Yes, sir.
So now, is this pole enclosed by this contour?
No, sir.
So shall I write p is equal to 0? What
Yes,
was
sir.
p? What was p here? We wrote this one now. What is this p? How did we define p
Pole.
here?
It's the pole of f of s,
It is the
which is enclosed.
it is the number of poles of f of s enclosed by the contour, a random contour. Correct?
Yes.
What is this p now for this specific contour?
It's 0.
What is, okay, how do you define p now here? It is the number of
It's
poles
the,
of GFS into HFS enclosed by the Nyquist contour.
yes, sir.
Does it mean to say if P is equal to 0, does it mean to say all the open loop poles are there to the left of the left half of the S-plane?
Yes, sir.
The point is, of course, try to understand, if P is equal to 0 in this particular case, in case of Nyquist contour, if P is equal to 0 means all the poles are there to the left half of the S-plane. Which poles? The open loop poles. Open loop poles are also equal to poles of 1 plus GFS into HFS. Done?
Yes, sir.
Okay, now we will not get the value of Z. What was this Z here?
It was the number of zeros.
Number of zeros of f of s enclosed by the contour, because this is an open loop transfer function. This is an open loop transfer function. I don't have 1 plus GFS into HFS. Correct? Since I'm having GFS into HFS, I cannot find this Z value. I cannot find this Z value now. Now, uh, in this expression, can I write, so you know that okay, n is equal to Z minus P. Shall we write Z is equal to n plus P?
Yes, sir.
So now, uh, what is this P now?
It's number of poles which are enclosed by the Nyquist
Is P is
contour.
equal to 0 now? In this case?
Yes, sir.
Now, can I find the value of n? Meaning, this contour which is there in S-plane, I want to represent this contour in f of S-plane.
Into f of s.
F of S-plane. So what is actually f of S-plane? It is 1 plus GFS into HFS. Am I correct?
Yes, sir.
Meaning, okay, instead of taking f of s, 1 plus GFS into HFS, if I take simply GFS into HFS, what happens? What is the difference between this and this here? Will you get this one? Will you get this one after making, okay, this is actually 1 plus. If you make it 1, if you subtract 1, will you get GFS into HFS? If you subtract 1 from this f of s, will you get GFS into HFS? Shall we get it? From this f of s, if I make it minus 1, will I get GFS into HFS? I'll get it.
Yes,
now, how did we define the value of n here? We defined the value of n as the number of encirclement of origin of f of s. Correct?
Yes, sir.
Since the plane taken is GFS into HFS instead of FFS, shall I slightly modify this encirclement instead of origin? Let us take minus 1 plus J0 as my reference point with GFS into HFS as my plane.
Yes,
Now
sir.
I will redefine the value of n now. What was the value of n here? N was defined as number of
Number.
encirclement by the contour in FFS plane. Number of encirclement of the origin of FFS. Correct? Since the
Yes,
plane is
sir.
FFS. Since the plane is FFS. If the plane is GFS into HFS, the definition of N slightly modifies to number of encirclement of not the origin but minus 1 plus J0 by the contour in GFS into HFS plane. Getting
Yes,
the
sir.
point now? Of course, is this origin, is it not same as minus 1 plus J0 in GFS into HFS plane?
Yes, sir.
Because we will be knowing the open loop transfer function, so that's why we are not going to FFS plane. Instead, we are going to GFS into HFS
G
plane,
of.
and we will look for encirclement of this point instead of origin. Getting the point now?
Yes, sir.
It is a bit not tricky. You need to simply get into the things. Of course, why we started with FFS is because that's how the n is defined as. So what is n is okay, how n is defined as? It is the number of encirclement, origin encirclement by the contour in FFS plane. So we are trying to slightly redefine the value of n by taking this as GFS into HFS plane. So what is the new definition of n? N is nothing but number of encirclement of minus 1 plus J0 by the contour in GFS into HFS plane. Correct?
Yes, sir.
Okay, fine. So now with this GFS into HFS, which is 5 divided by S plus 4, I need to write the contour that will exist in GFS into HFS plane. Can you see this is my contour?
Yes, sir.
Maybe here, if you just go back to our problems, can you see this was your S-plane contour? This
Yes,
was your
sir.
S-plane contour. This is your f of S-plane contour. Correct? We could able to know what
Yes,
is
sir.
how many number of encirclement. Now, what we'll do is, how does this contour, which looks like this semicircle in S-plane, how does this will look in this GFS into HFS plane? Getting the point?
Yes, sir.
So I will write a GFS into HFS plane. I will write one to one mapping of all the points of this contour, and I will look for which point? I look for minus 1 plus J0 point. Is it
Yes, sir.
encircled or not? I look for it. Correct?
Yes, sir.
We will look for whether this minus 1 plus J0 is encircled by the equivalent contour of this in GFS into HFS plane. Okay, we'll do this, we'll continue this. I think you're all free at 11 also. If you are free, okay, we'll just meet at 11 o'clock. Thank you so much.